We're good to go.
All right. Thank you everybody for having me. I'm super excited to come here and talk about SBOMs. So Matt already did a show of hands. Who's familiar with SBOMs? Just to recap. All right, so fairly small percentage of people. I think that's going to change pretty quickly in the coming years. So timely talk, I presume. And my clicker's not working, so there we go. All right, so who am I? So my name is Viktor Petersson. Done a few startups. I've been in the London DevOps scene for quite some time and excited to be back. And the reason why I got excited by SBOMs, I actually got introduced to the world of SBOMs, was in my other company, Screenly, we do secure digital signage and we sell to like NASA and like very high compliance industry, banks and so on. And I started seeing requests from our customers saying like, hey, can you provide with SBOMs for your product? And I was like, okay, first time I was like, oh, sort of normality, and then second time around, you're like, okay, there's probably something here. So I started looking into it, and there are quite a few reasons why this is happening now. And then that got amplified then when we joined a program called Secure by Design, which is a US CISA project from that basically tried to ensure everything is secure. So like from hardware down to software, radical software trespass and all that. So I started myself in this world, and I joined some of the CISA working groups, working one of the groups that does reference implementations for SBOMs, and then that really got me into the SBOM. I'm a pretty frequent member of those various meetups and meetings around that, around CISA in particular, so it's still very US-centric. So what are SBOMs? Well, SBOMs is really from bill of material, which is a concept that's used in manufacturing for decades by now, and really stands for software, so it's software bill of material. And the best way to describe it is a list of recipes that goes into your software. So basically what makes up your software. And this is usually generated as a JSON file and shipped into your CI/CD pipeline, usually built in your CI/CD pipeline. Oh, sorry, is it not working? Oh, sorry. All right. So it's usually a JSON file that is spitted out and usually builds in your CI/CD pipeline. I'm going to walk you through exactly how that works in a minute, but generally speaking, it's a JSON file, and if you really hate yourself, it can be an XML file. But most people do JSON files. So why now? Why are we talking about SBOM now? Well, the big tipping point for why SBOM became kind of a talking point a lot across the entire tech industry was something called the US Executive Order 14028 to be specific. And that was written in 2021, but didn't take effect until this past summer. And what that means is that if you're selling software to the US government, you need to provide an SBOM as part of your process. Otherwise, you're not allowed to sell to them. So that was kind of the first big tipping point that forced a lot of medical industry, a lot of defense industry to start shipping SBOMs. So like you started really seeing early adopters in those industries in particular. This was then kind of magnified by EU Cyber Resilience Act, the CRA for short, which is not live yet, but it's coming out in the coming years. That is expected to basically force a lot of industry to adopt SBOMs. Then we have the NIST Cybersecurity Framework 2.0 came out earlier this year. Doesn't explicitly state SBOMs as a requirement, but stopped just shy of that. So basically they're calling for software transparency, but stopped just shy of SBOMs. All right, so what are SBOMs used for? Like we talked about, okay, it's a JSON file, cool, but what it's actually using is it has a list of all your components that goes into your software. But what is that actually used for? Well, generally speaking, it's used for one out of two buckets. One is for security audits. So if you have an SBOM for your entire software stack, you can chuck that into a tool and you get a CV result out of that. So it can tell you exactly which CVs you're affected by and where they are. So that's a big use case. A lot of, I know in fintech, for instance, it's fairly heavily used. A lot of banks, they use it already for this as a gatekeeper almost for what can be deployed. But that's one of the use cases. The other use case is from a license compliance perspective. So a lot of companies out there are very nervous about overly liberal open source. I'm particular about GPL3. It's banned in a lot of larger enterprises. So it's important that the compliance team in these companies know what goes into it. So license is one of the things that you would go into the SBOM. All right, so we know roughly what an SBOM is, and let's talk a bit about the generation part. So this these three building blocks, they will be kind of outline of the talk. So I'm going to start about the generation process, the distribution process, and then finally the analysis part. So the generation part is building a SBOM, sometimes called authoring. If you look in that CySA document, they call it authoring, which I think is a confusing word for it, but that's what they call it. Then they have a word for distribution, they call it transportation, but it's the same thing. If you come across these things, those are the same thing in the framework. But this is kind of the life cycle of an SBOM as an SBOM producer, which is very different than an SBOM consumer, which is if you're buying software, right? But this is the production steps. So SBOM generation. This is how I thought it looked like. You get one of the many SBOM tools, you run a command, and you have val SBOM, you move on. Or you go to GitHub and say, oh cool, GitHub does SBOMs, great, download. Oh boy, was I naive, because that's nowhere at all how it actually works in the real world. When I started merging my world about 8-10 months ago, and I started running into these issues over and over, my initial gut feel was, I must be completely overlooking something, missing something obvious. It surely can't be this hard. And there is something called an NTIA minimum element, which is kind of a gold standard for what an SBOM should look like. And that's what a lot of the regulation calls for, that you should be compliant with NTIA minimum elements. So that was kind of the bar I was trying to reach. But it was not easy to do that. I had a conversation with a lot of people in the community, including people from like very serious industries that do SBOMs, have done SBOMs for a long time. And I kind of sanity checked all my assumptions, like, am I missing something obvious here? And after having these conversations with a lot of people, like, no, you're not. It's actually that challenge to produce a good quality SBOM. It's not impossible, but the tooling is, I think we're doing an industry a disservice if we kind of try to brush over those complexities. So let's start looking at the actual generation part of it and those steps from the generation. So within the generation block, I would kind of define 4 steps to that process as part of the CySA working group that I'm part of. So you have the creation part, which is when you actually create that SBOM. So that's the authoring, as they call it in CySA language. So that's where you generate it. And there are a lot of good tools out there that can do this pretty well. But the output you get from these tools only takes you to the first step. It's very rare that they complete all these tools, all these steps. So once you created your SBOM, now you need to what's called augment it. We use the terminology augment it, which is that you need to enrich that SBOM with who you are. Things that can't be automated. It's like, what's the license of your software you're making? Who are you? Who are involved with this? What's the company behind it? What's the supplier? All these things are needed to create an SBOM that is NTIA compliant. So that's a manual step that's often overlooked in the conversations that we're having with SBOMs, about SBOMs. And then you have the enrichment phase. And the enrichment phase is really important. Some of the generation tool, depending on what stack you're using, some languages are better than others, will do a better job on this. But oftentimes, this step requires using some kind of tool that looks into your dependency tree that you got from your SBOM, and then we'll hit up various APIs to enrich that data, like what's the licensing for this library, and so on. And then it will automatically populate that. So it enriches it with more metadata about every single package in there. And that's, again, that's a requirement for being NTIA compliant. Then the final step, which you can do in a later step, you can do in the transportation or distribution phase as well, but we included that in the working group. And that's the consolidation. So if you have a very simple example, so you have like some part of Python code running a document. Well, if you want to be strict and actually adhere to the CycloneDX, I'm doing to the second, but if you want to adhere to those formats, you actually need to get 2 SBOMs, and then you have a pointer that references those 2. So you don't have one SBOM for the whole thing, you actually have a tree structure almost. And then once you've done all this, it's really like a hairy problem that requires a lot of manual JQ usually to manipulate JSON files together. All right, if you have some kind of exposure to SBOMs, like you've probably heard there are different formats in the SBOM world. And there's kind of, we don't like calling it format war, but there are 2 competing standards essentially in the SBOM world. There is something called SPDX, which is from the Linux Foundation. That project started kind of a more license focus and more theoretical focus on how to drive an SBOM. So we focus a lot about the licensing for the components, and it has a very different approach to how you construct an SBOM compared to the other format, which is CycloneDX. And CycloneDX, at least from my vantage point, is the format that is gaining more momentum. And CycloneDX started actually from a more real problem-based solution. That's a need for problem. It started ServiceNow and was kind of part of the development of this, and was donated then to OWASP and is under the CycloneDX umbrella at OWASP. So now we have two competing formats in a world that is very much early stage, right? Tooling's not there. We have two competing formats. Not looking great. So what do I think is going to happen with one of these two? Well, I don't think anyone's going to win. So the classic XKCD, you have two competing standards, then now people say, well, that's stupid. Why don't we do this? And now you have a third format. So what I think is going to happen is that there's meta formats on top of this that will basically capture all the data, and then you just spit it out to whatever you want, because there are different use cases for both of these formats. So there's something called proto-bombs that is kind of early stage, but that is what a lot of big boys are backing right now, a lot of involvement in that. So my gut feeling is going to be like the format in a sense will be relevant. It will be kind of a meta layer that you can spit out to whichever you want, and that's kind of that's the world I would like to see as well. All right, so let's talk a bit about the tools. So to make an SBOM, you could craft by hand, but you probably shouldn't. It's a lot of work. So let's talk first about the generic tools. So the tools that you most frequently see when you emerge into the world, it's going to be Sift from Anchor and Trivy from Aqua. They are the tools that are kind of pretty commonly used out there. And people that are kind of well-versed in Docker, they're familiar with Docker Scout. Docker Scout has an SBOM generation feature. Well, actually, Docker SBOM's generation feature is actually using Sift behind the scenes. So it's actually just a extraction layer on top of that. So we have these layers. Depend on what I mentioned before from GitHub, kind of does SBOMs, but I wouldn't trust it for reasons that I'll get into in a moment. You then have domain-specific tools, and both CycloneDX and SPDX do produce their own tooling, and it's all like very much structured around specific frameworks. So there's a one Python, there's a Rust one, and so on. So language-specific ones. So and CycloneDX in particular is good at creating these toolings, in my opinion. Now, an SBOM captures all your dependencies. And when you're talking dependencies, you have two levels to this. So you have your primary dependencies, and then you have transient dependencies. So your dependencies of your dependencies, and that can be dependencies of dependencies of dependencies. That can be a very big tree of dependencies. And it's easy to get caught up in just doing primary dependencies when you're starting out, but if you actually want to go all the way, you are doing all the transient dependencies. And I'll talk a bit about in a second how that looks. But we talk about these tools generating SBOMs, and one of the deliverables that I had in my working group that we're doing at CySA was to deliver upstream to the Django project SBOMs so they can have them in the repo up there. Great idea, right? Well, as it turns out, we can't. And again, this is kind of hard to read, but the reason why we couldn't do this is because if you look at the dependencies here, you can see these are ranges, right? So it's greater or equal to these packages, which means that it's impossible to generate an SBOM in the source stage, because you can tamper with that, you can say a specific version, and that would still be fine with Django, right? So it turns out we couldn't actually do it for Django, and Python is a good example of where SBOMs actually, source SBOMs is actually difficult. So that brings us to source versus build SBOMs. And there are two ways you can build an SBOM. You can either do it from source, meaning that you run some tool against your lock file, depending on what language you're using. The quality will vary a lot. More modern languages like Rust and Golang, you can generate pretty good dependencies there, or pretty good SBOMs there, because they have a lot more metadata in there. And it's kind of more standardized to capture all your transient dependencies in there. But if you look at other projects like Python, it's pretty common to only list some of them, like you might have ranges, and in that case, it's impossible to build a good SBOM from there. So the best practice is to do an SBOM on build. So that means that in your CI/CD pipeline, when you build your source code and you build your Python package, or your Docker containers, or whatever you do, once you've done building that, you then ask, okay, tell me every Python package that was installed. And then you use that as an input to your to your SBOM. And that way you capture all your transient dependencies, regardless of language, more or less. It gets a little bit hairy as well, because one thing that is often called for in some of these reference implementations is that you should include hashes in there as well. So not only should you say this package, but this package, this version, and this hash. Depending on what language you're in there, it makes it a lot more difficult. So like again, going back to more modern languages, Rust and Golang, a lot easier to accomplish. Python, NPM, and like a lot more difficult. Not impossible, but a lot more friction. All right, so we've built our SBOM, but that's just a very simple starting point. So if you envision any realistic product, you're not going to just have one SBOM, right? You're going to have, okay, so imagine a very small SaaS product, right? You're going to have, what, 10 microservices perhaps? Maybe you have a client software. So you probably have some front end with that as well. So for even a very basic use case for SBOMs, you're going to end up with probably a dozen SBOMs. And you can't just squash them all together into one file, because then you can't really backtrack to, like, if you find a vulnerability, like, okay, where is that vulnerability? So you're probably going to end up with a dozen SBOMs, and you're probably going to end up with something that looks more like this. So here's an example that I drew up, which is an example of a smart thermostat, right? So what you're selling to your end customer is a smart thermostat. That smart thermostat is a piece of hardware that has some piece of software on it, right? So that's one part of this tree. And then on the other side, that smart thermostat speaks to a backend. That backend probably has a front end. It has an API, probably multiple services. So in even like the most simplistic example, you end up with like 8 or so SBOMs, right? For any real use case. So I kind of try to mentally map this as a product tree, right? So you have product, project, and then components. And that kind of structure you do things. So you have this now, managed to bake all this together, you built an SBOM. But every single of these SBOMs, they're kind of a dynamic element, right? So every time you deploy to production from your CI/CD pipeline, dependencies can change, right? If you're a big organization, that can change like 1,000 times a day, right? You can't manually like email SBOMs to your customers 10,000 times a day, right? So you kind of need to treat this more like an object portal where you can go and get, and that's, we'll go into that in a second, but that's one of the pain points I discovered in my work of implementing SBOMs at Screenly, which is like, how do you actually deal with this in the real world? So we talked a little bit about security, and an SBOM that's just a text file is great, but you can't really trust it because it needs to be built in your CI/CD pipeline. But even if you do that, how can you trust that it hasn't been tampered with? So hashes was already mentioned for all your packages. You can also hash your actual SBOM, but then attestation comes into play here. How can I know that that SBOM was actually built and not tampered with in process? So if I can use attestation, so in GitHub now you have really good built-in attestation essentially with these functionalities. So now you can actually start getting some cryptographic identity on this, and I can say, well, this was built in my CI/CD pipeline. All right, distribution is the next category in the workflow or lifecycle of an SBOM. And the way I think of it is like handling SBOMs today is very much like we shared source code in the 90s. Like you're literally emailing them. I've had a lot of conversation with CISOs as I was starting up SBOMify, CISOs from various sizes, and I asked them, like, do you ask for SBOMs? And a lot of them said, yeah, we asked all our vendors to provide us SBOMs, which is great. And quality of those SBOMs is probably not always great, but at least that's the starting point, right? So then I asked, okay, so how do you organize this? Well, a lot of these people just said, well, we chucked them into SharePoint. And then you're like, cool, but how do you track that? It just sits in a folder, like it doesn't actually add any value. So this sentiment was very much echoed in another CISO working group, which called the Sharing Primer. And they basically echo the same findings when they spoke to other people. They're literally just copying and sending emails. And again, if your SBOM can change 10,000 times a day or 1,000 times a day, if you just keep pushing CI/CD, that's not a viable approach. It might be a viable approach for very specific projects where you have releases every month, and then you can say, oh, here's a release artifact that can be out. For that use case, fine, it probably works. But for anything more dynamic, not gonna fly. So that was the problem. So that's kind of why I started building SBOMify. So SBOMify is basically a hub that you can ship to, and you can invite your customers to, and you can ship your SBOMs, and you can invite all your customers to, or vice versa. So that's what I built, and there's an open standard that called the Transparency API, Exchange API T project, called Project Koala as well. It's another nickname for it, which aspires to create like a global standard for how you share SBOMs. So we look into adhere. So I'm part of that early working group under CycloneDX on how to actually build a structure around that. All right, the next part is the analysis part. And there are really two major blocks in the, two major products that are really used in the open source world around SBOM analysis. The first one is Guac, which is more like a database with a DSL that you can query SBOMs. So you can ask it questions like what's the vulnerability for this or that. And then there's a dependency track with the CycloneDX project that allows you to upload SBOMs and then have more graphical interface, but it also has an API. I've seen companies using these as kind of gatekeepers. So like when you're shipping software, their CI/CD pipeline will basically gatekeep based on the output from these tools. So those are two of the most popular tools in the open source world. There's no shortage of commercial vendors, but I'm not going to bother including all of them here. All right. We've talked a little bit about building a single SBOM or like a few SBOMs, and kind of have this graph of how you build a few SBOMs. Like you have a product, and then you have this. But when I started immersing myself in the CycloneDX world in particular, they had something that I thought was super interesting, which is they call them OBOMs. And OBOMs is basically a much bigger abstraction. And I don't think it's been talked about much about in the tech world, but SBOM is like a small part of this. You then have something called SBOMs, which is a cryptographic bomb, where you describe how you're doing cryptography in your software. They have something called SaaSBOM, and that describes your infrastructure. So like this is running in Kubernetes and Google Cloud or whatever. And it's almost like a full service registry. And it's almost like an alternative way of doing service discovery in a standardized way that fits together into something bigger. You also have MLBOM, which is about machine learning. HBOM is your traditional hardware bomb, so that's what your original bomb would be. It's like if you're selling a hardware product. And then you have something called VEX. So VEX is something called a vulnerability exchange, which is essentially, if you have your SBOM, you run that through a CV scanner or like an analysis tool that you find your vulnerabilities. A VEX file is the output of that, where you can annotate and say, this vulnerability is not severe because X, Y, and Z. Like it's your traditional like CISO work, right? So you can annotate that, but then you can attach it as like a complementary file to this. And on the very top level, you have something called OBOM, which is operational bill of material. And the idea is, and I think this is a really interesting concept, is where you tie them all together, right? This is probably 10 years out, because people are struggling a lot only with SBOMs. But I find the concept around this very interesting, because you can capture entire product, all aspects of your product. Because you can also imagine in a SaaSBOM or in an SBOM tangential, firewall rules, or like if you're selling a hardware product, what ports does this product need to talk to? So you can tie it into your firewall rules and so on. So there's a lot of interesting stuff going on, in particular in the CycloneDX world, about how you can describe this and create this meta format for how your runtime looks like. All right, so I spent the last 10 months or so kind of immersing myself in the SBOM world, and it's been really fascinating. I've got to know a lot of the key players in the SBOM world, and it's a really great community if you guys want to involve in that community, both in the SPDX and the CISA side as well. And oh yeah, I forgot to actually tell you what CISA is. CISA is, for those not familiar with CISA, it's a government body that advises all the other government bodies how to do security. So they have, basically SBOM lives under the CySA brand, and they kind of act as a steering committee kind of, but they're not controlling any of the individual format, but more like the direction. So they have a lot of community and events around the SBOMs. All right, so then going back to NTIA, that is the gold standard you want me to today. And it's I want to say that it's easier to do than not, but it's actually rather complicated today to meet the NTIA standards. We at SBOMify are looking to do some of the things to help with that, but it's not as great as you thought it'd be. It's a lot more difficult to produce it well than I thought it was going into this. So with that, do you have any questions? Yes, well.
So, a question, because I know a lot of people that are in an IT asset management field.
Yeah.
There's a Venn diagram, right? Where's the overlap? Can you describe that relationship
between
IT asset management and the bill of materials, where that fits? It's a subset, or?
I don't think I am qualified to answer that, because I haven't actually seen that overlap. I haven't seen those that much, but it's such a fast-moving field, so what was true yesterday is not true today, right?
It's usually about licensing, though, making sure the licensors are valid. So.
There is, so like, in more sophisticated organizations, SBOMs will not be used for one thing, but rather for multiple things, so both for license compliance and for security audits, right?
Sorry.
So, yeah, I'm not sure.
I was going to say, the whole concept of the SBOM and the OBOM reminds me of that elephant in the room, the CMDB, insofar as it's not the same data, but it's that kind of big database which has got everything in it that, and I think most people will probably corroborate, CMDBs are never up to date. Every organisation you've ever worked in, CMDBs are out of date. So I guess, how can we bake into this concept from the start the fact that it's not relying on this manual updating process that clearly with a CMDB never happens?
I think for this to work, it needs to be fully integrated into your CI/CD pipeline, right? There's no other way this could possibly work, right? And I think the push that was needed to get the budget for doing this largely comes from compliance. And if there's revenue at stake, if you do not get your house in order, budgets will be made, right? So I think the push gonna come from compliance, but then there'll be like an epiphany once it's actually in there, like, oh shit, we can do a lot of cool stuff. Or more realistically, they're gonna find, oh crap, we knew about all these vulnerabilities we had in our system that we had plausible deniability about because we had nobody who said we actually had it in there. But yes. Yes?
If I introduce SBOMs into a project from the start,
yes.
What's the effect on speed of delivery?
Speed of the generation or speed of
delivery of the project? And quality of the project, like as a quality, I'm talking about bugs.
So I think if you do that from the start, you will be in a much better position to understand what's going in there from a security perspective, right? So finding like dependency bot and all those things at GitHub and whatever you may be using for detecting vulnerability in particular, they're not fantastic because they don't have all that data. It's like that's why GitHub's SBOM generation can never be perfect because they don't have all the data because that's generated on build. So if you do that from the start, you'll be in much better position to actually understand what goes into your software, be on top of vulnerabilities before they actually impact you. So I think that's like getting that in a blueprint early on is easier because if you start with all the requirements there, I think it's going to be easier to actually, rather than try to retrofit everything that we had to do at Screenly.
Yes, but do you know how it affects the speed in percentages?
The speed in
of delivery.
Of the sorry?
Speed of delivery, how quickly will the project and the quality of the project, will it increase it, decrease it, the speed?
I think it depends on the teams. I think it's hard to give you a generic statement of that. I think it depends on how sophisticated your team is and the quality of the code base, and I think there are too many variables to give a single answer for that. But yeah, sorry.
Okay.
Are we out?
Are we done?
I don't know if there's more questions. No, I have no more slides, but if there's more questions, that's all.
More questions. I think we're a little bit on time.
All right.
That's all right. So, fine, Victor.
Thank you.
Thank you for a brilliant talk, Victor.